Hello. So far we've learned about moment of a force about a point, both how to find it in a scalar and 2D problems, and also in vector format and 3D problem. Here we're going to learn how to find moment of a force about an axis. Here, to just remind you of what we've covered so far, we have force F and we find moment about point O. We use cross product, which will result in a vector. So it's going to be position vector from that point to line of action of F, cross F. And you can see we got to find determinant of this matrix, and it's going to give us a vector. So it's something I, something j, something k, a vector. Now, in some applications, I have two examples here, but there are thousands and thousands of examples. We want to find component of moment or the magnitude of moment in a specific axis. So if I'm trying to change spare tire or flat tire, and if I'm applying that force, of course, it's going to create a moment about point O or about XYZ axis, but I want to see how much of it is actually used to loosen the knot. Or here, with the force P, a person is creating a moment of M sub A using this flex handle socket wrench. Does all of MA act to turn the socket? I don't think so. How would you calculate an answer to this question? So before moving on, I want to mention something. When you find moment of a force about a point, we are finding moment about three axes, about X and Y and Z. So this is component of moment about X or component on X, component, let's just say Y component and Z component. It is a vector and we are finding its component on X, Y, Z axis. What we want to do now, we want to find about one axis that is not any of those two. It's not X, Y, or Z. So moment of a force about an axis, I want to remind you something. So read it this way. Component of moment along an axis. Read it this way. Projection of moment along an axis. Okay, when you read it that, what does it remind you of? What do you recall? Where did you hear that before? Let me help you a little bit. I have force F, which is a vector, and I have line AA. I'm asking find component projection of F along line axis, whatever you want to call it, AA. Do you remember that from chapter 2? In order to do that, we found unit vector of this line, and all you had to do dot product those two by each other. Remember that? To find a component projection along a certain direction, we dot product it with each other, and this will result, dot product will result in vector or a scalar. It will result in scalar. Okay, I'm going to draw the exact same thing. This is a vector. I like to call it vector M. It's a vector Just because I call it something else doesn't change anything. And it's not so straight. Let's find component projection of vector M along line or axis AA. So I'm going to do the exact same thing. I'm going to do moment, which is a scalar, sorry, vector MA, I don't want to call it moment yet. It's going to be M dot unit vector of AA. Which is a scalar. So now the only difference is in chapter 2 we dealt with forces. Now we deal with the moments. But the nature of them, the concept, the principle is exactly the same. To find component of a moment along an axis, all you have to do is dot product the unit vector by it. So let me write the equation for it. So moment about a point, what I had was R cross F. Moment of an axis, about an axis, is R cross F unit vector of that axis. In a lot of textbook you see, because remember, A dot B same as B dot A. But we couldn't, because this is a scalar, it really didn't matter. But with cross product, we couldn't do that. Because then this is a vector. This is just to remember. So I can just flip these two. I can say unit vector of AA R cross F. Okay, so let's see what does these mean. So the position vector, it is position vector from somewhere to somewhere. For a moment of a force, I'm glad that I wrote this here. This position vector was from point to line of action of F. So can you guess what this position vector is from? Is from, instead of point, axis, to still line of action of F. But don't forget, anywhere on the axis to anywhere on line of action of F. And the U is unit vector of the axis. So now comes the determinant. Before, we had the second row was position vector Rx, Ry, and Rz. Let me write it again. Position vector from anywhere on axis to anywhere on line of action of F. We still have that. Rx, Ry, Rz. Components. These are components. Third row, before we had components of F, meaning Fx, Fy, Fz. Pay attention, there's no IJK, just the components. Fx, Fy, Fz. Before, when we had the point result was a vector. The first row we had ijk. What do you think we have in this this determinant now? The first row are components of unit vector AA, meaning ux, uy, uz, these three components. Now look, in this determinant, do you see any ijk anywhere? I don't. These are all going to be components. These are all going to be scalar numbers. So you're multiplying a bunch of scalar numbers together. You're finding determinant of a matrix, which is going to be a scalar. It makes sense. Let's look here. Moment of a force about an axis is a scalar, is a magnitude, is a component, are the same thing, is a projection. And it results in a scalar because it's dot product of two vectors. So this makes sense now. Vector dot another vector, so it should result in a scalar. Scalar. And this proves it. There is no I, J, K anywhere in this determinant. And that's how we figure out moment of a force about an axis. So here just kind of a summary of what we've talked about so far. This is just to remind you, moment of F about coordinate axis. This is about a point, which is a vector, which is about three axes, x and y and z. It gives us about x, y, and z. But then this is a vector. Vector, as you can see, it has mx, my, mz. It has three components. Now we want moment about an axis. This is a scalar. This is a component about an axis. This is dot product of the unit vector. This is lambda, by the way, which same as unit vector of this arbitrary line A, or just use lambda for it. It's the same thing. This is a scalar. So this is again a summary, a comparison. Moment about the point is a vector, cross vector which result in a vector. This one is dot product of two things. Vector dot vector results in a scalar. Some textbooks called it mixed triple products. So again, I want you to be familiar with that term, and if you see it somewhere, don't get confused. Moment about, this is moment about L, or component on L, or projection on L. You can call it all of these, is unit vector of L dot moment that we have, and result again is a scalar. In next video I will do examples on moment about a specific axis, and you're going to get a lot of practice and get familiar how to use these equations. Thank you.